Hello, can you hear me? All right. So I've met a couple of you yesterday. We went out for barbecue, pork, steak, and I overslept after that. Anyway, so I am not going to talk too much about technology. But what I'm going to talk today is about Postman. The story of Postman, how it started and how AWS was a very close part of it as it has reached the point it has reached now. So, yep, but everybody spoke about the user group, so I stitched up a last moment slide. The best I could do was copy paste from the AWS's own website. And as usual, what we do best in India, we have lots of them. So we have lots of user groups, and AWS Bangalore has like 5,000 members, and we are always very active towards helping out people. And if you have questions or anything, and I'm from the Bangalore user group, the link is out here. We are always mostly on meetup.com. Managing Facebook becomes a huge problem. Moving on. I hope Google Translate did a good job of whatever I was trying to figure out, right? But I did get two words when I came to Seoul. The first thing, Seoul, rather. So when I came down, I actually still know Kamsahamnida, which means thank you, or some, and I also learned hello. Now, about Postman. So before I tell you what we are doing and how we did, I think it fits that I tell you the scale at which Postman is operating now. It is 2017, and we started 2014. So I am going to start from a point when we were only 3 people working from literally, three of them starting from their different offices and then moving on to making an organization out of it, and how we used Postman throughout the journey. So Postman right now has almost over 4 million users, and I'm told there is like 1.5 million more in China, but we can't get our analytics to figure that out yet. But we have Jackie from China here who can, I think, give me more insights someday. We roughly have 2 million monthly active users and 500,000 daily active users. That means at any point of time, there is roughly 200,000 Postman clients connected to our servers, at this instant. How many of you have used Postman here? So this gives me an advantage at least. You know what I'm talking about. And I'm sure that when the translation happens, a lot of people will already know what Postman is about. So I hope they can relate. So Postman is a tool that allows you to, design APIs. It allows you to mock your APIs. It allows you to test your APIs. It also allows you to document your APIs. And other than that, it also allows you to monitor your APIs from different regions and give schedules, etc., etc., etc. So these mean that we have to consume a lot of services and resources of AWS to actually provide this. And to beat that, all these are for free. So you can do all these using Postman for free. That means to support this number of users, we have to literally tune our services to be able to serve as many users as we can at the least cost possible. And also when we do have subscription charges, but we need to keep it low, so by ensuring that our infrastructure costs are low. So our stack. So we have roughly 30 plus microservices. And roughly we get 10 million requests per hour during the peak hours. And we have roughly 140 gigabytes of data coming in per day. So our databases have actually scaled beyond what MySQL supports, and we had to move to Aurora because we have crossed 6 terabytes that the max MySQL could provide. Now, no, it should go back here actually. So, right. So we started in the year 2014. 2014 means we had to make some choices regarding what technologies we will use in order to proceed. So we had the option of starting from scratch. A lot of organizations don't get the option to start from scratch. So AWS has a lot of tools that allow them to get into their ecosystem using systems like OpsWorks, or people those who are already in using containers get into using ECS into their infrastructure. We had the opportunity to start from scratch. And we kind of did some digging into AWS's various offerings. But that was much later. Before even this happened, we were actually wasting a lot of time trying to set up all these servers ourselves. So in 2014, we had a small team. I mean, 3 of us, 4, I think even less, 3. And our goal was we are going to provide the best services that we can for our users. And with whatever skills that we have. And this was what our faces looked like. Every weekend, while everybody would go partying, we would go to party and be the odd one out sitting in the corner trying to figure out why our servers are going down. It was a pain because when we first started our online services, we already had 500,000 users. And we were first starting our first service. So we came online and within hours, we started getting activity and we had to scale. And in the first hour, the first thing that happened is our services crashed. We were not on AWS back then. But then we went about manually logging into the machines, doing everything that we can to get the service back up and running. Finally, we got the opportunity to explore AWS. That is Beanstalk. So we got into the partner program that AWS provides that gave us some credits to start with. And we figured out that would be a good way to start. And at that point of time, we discovered Beanstalk. Why Beanstalk? There are a lot of tools that are presently available. They are technologically advanced. You can do this, you can do that, you can do a lot of things. But can you go live with them right now without worrying about configurations and get your product out there, get your startup out there? We have some statistics. We find that a good percentage of startups actually die out in the first and the second year of their going live because they are spending too much of time and effort to get the operations and the things running which they can easily offload. We rather chose to concentrate on our product and figure out offload as many things as we can to AWS, preferably Beanstalk. Beanstalk being one of the few AWS services which actually uses almost all other AWS services. So instead of building something new like ECS or OpsWorks, OpsWorks is also on those similar lines, what it does is it orchestrates as many AWS services as possible using best practices that AWS thinks is applicable for them. And this was our face. Trust me, in 1 week, we were amazed. Over 1 week. It took us a week to get up and running there, but once we shifted, we had our weekends back. The first thing we realized is that we can actually party without worrying that Friday load is going to kill our services. And that is an amazing feeling. Until your Fridays are taken away and Saturday, Sundays are taken away, you would not realize how amazing a feeling that was. So Beanstalk plus Docker. This combination is a beautiful combination. With Docker, you kind of make yourself a bit more risk-free. Plus, you also make yourself the ability to tie your infrastructure along with your code. So I have So last time I spoke about this in one of our conferences back in India, and there were like lots of people there, and I asked them, how many of you are using Docker in production systems? We were attending cutting edge meetup, but I really asked a question, how many of you are actually using Docker in your production scenarios where your main primary product is actually built on top of Docker? So only 2 hands got up. That means, yes, we talk about Docker, we talk about all these technologies, but we hardly get to use them as the daily bread and butter for our startups or our products. So what we did was, okay, we are not going to build something complicated. We will just start using Docker to standardize our infrastructure. We will have a single container which will have whatever we need to define our basic systems, so that every services that we build on top of it will have a common structure. And then we committed it along with our code. That means developers know what they are dealing with. So from here it started a different way of thinking. We are right now 50 odd team members. Roughly you can say 80,000 users per person being addressed. Now, the thing that we did was we unified. As a growing startup, we wanted to ensure that our operations and development teams are unified. They are together, they are one. So your developers know what they are building and what they are deploying on. And there is not what we call as the ops fight, and we don't say that, hey, it worked on my machine, I don't know why it is not working on production server. So these issues were removed. So what did Beanstalk and Docker give us? It actually solved all our pressing problems, all. So what we started was, it started working with what Beanstalk has core in its principle as called the auto healing. I mean, that's what we talk about most microservices, that what happens when things go wrong? What can you do when things go wrong? What happens when your Windows server goes blue screen? You restart, right? Yes. So when things go wrong, the first thing that you most of the time do is restart. There will be a time when you'll have to even do that with your car. Imagine Tesla or some hardware or some software hanging, you're driving and your car hangs and you have to restart. So what we do is restart. So auto healing is one of the core principles of Beanstalk. So when you deploy something, it closely monitors your services, and when it goes down, it will restart your services. Something as simple as that takes so much of complexity to set up, in whether you think about Kubernetes, whether you think about other places. It's just too many steps to worry about. As a single or 2 or 3 developers, all these systems and settings are okay. But once you are running, let's say 100 services, how do you consolidate all your settings? How do you put all your logs for permanent retention and then rotate them back into Glacier? There are questions that come in. Some applications can deploy immediately. Some applications need to be gradually deployed, so that you don't create a cascading failure. So a lot of these things are looked into and already pre-solved in Beanstalk. That's what we found. And we said, okay, we'll spend time building Postman and let AWS and Beanstalk take care of the services. So once we actually deployed Beanstalk and went live with our first service, this is usually what roughly we started using from day one. That means we had our application server, which was surrounded by Docker container, and if Beanstalk is taking care of everything except RDS and Elastic Cache, which we manually provision, other than that, I am right out of the box eating up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 AWS services straight out of the box. This would have taken ages to configure, ages to realize what are the best practices, and God knows what. And since they're already configured, as a part of your company, you can spend time even exploring and learning what these are, if you haven't encountered these already. Now, let's say, how many of you have used SSL Manager, ACM? Have you provisioned your SSL via AWS till now? Any one of you? Henry out there. Okay, fine. Who else? So we have, but we did not require too much of expertise to do that. Exercise is also a word. What we all had to do was click a drop down, select the domain name, so accept the I agree email. It's automatically added with the Beanstalk. It automatically put into your load balancer. You just go to your drop down, select, and done. Obviously, I could do that all by myself. I could provision them. We actually have a service which every time goes to SSL provisioning in Let's Encrypt, gets a free SSL, gives it to your custom domain. Yes, we do have expertise to do that, but we chose not to because things are ready. So the time we saved while in configuring AWS SSL, we invested the time in providing free SSL based custom domain services to our customers. That's the time well spent. So an ops or an infrastructure work that your customer cannot see is of no use to your customer, however technologically advanced it might be. So we moved on. So what are the things that we had? We had near zero downtime. So till date we had 99.9% lifetime uptime, except for scheduled maintenances that we had, I think, scheduled twice in all these years. So things that started working well: hot reboots, hot swap, orchestrate, reboot one server, then the next, and then the next. When all of them finish, check their health. When the health check completes, come back and then get all the services up again. Now, if you were to configure all these slowly by scratch using your different tools, it's going to take time. And then standardizing it across different services will also take time. So we got hot reboot. We got live deployments. That means you got your code, put it in. Here can be a small philosophical difference out here. You can automatically commit your code and it will show up. Maybe one day we will do that. We actually implemented that. But then we realized we lost the joy of pressing that deploy button. When you commit your code, you get your versions up, and then you have to press that button and it is deployed. It is a different connection between you and your users. And if it was just a commit on your machine and it would just automatically deploy, it's a huge disconnection. You are humans building things for humans on services created by humans. So we haven't automated that last mile. We will one day when we maybe have 100, 200 developers, different services, maybe 100, 200 services, God knows. But at least not right now. So what we do is that we have a simple command line which packages our code. You get a simple zip file. We go and click upload and deploy. And once we do that, it is automatically archived in all our application versions. In fact, we roughly have almost 7 terabytes of all application versions, all logs that were ever generated by Postman from the day Postman services came up. Why and how? Because Beanstalk already provided log rotation, log retention. So hourly it would take logs away from your services, it would put into your system, and you could put it back into S3. And then we added simple additional features to back them up into Glacier. And that solved our problem. So we had hot reboot, we had live deployments, we had live rollback. So this is another important feature. I think a lot of Kubernetes and ECS, they are coming up with all these things, that when you deploy something and the deployment fails, it immediately rolls back. This is an amazing advantage. Now you can actually prototype way faster. You have lesser things to worry about. Okay, what if my entire production service goes down when I deploy? Yes, this will be a huge problem 3-4 years down the line when you have loads of customers. But as a startup like we were back in 2015, we wanted to go out to people fast. Maybe it might give us a downtime of a minute if there was a bug. but not, at least that should not prevent us from deploying twice a day to production. Obviously, as we grew, we put some rules around it. Rule number 1, never deploy on a Friday. Rule number 1, never deploy on a Friday. And if anybody tries to deploy on a Friday, ensure that the deployment is scheduled on a Saturday. So that you have to come to office and deploy on a Saturday instead of a Friday. So we got live rollback, we got alarms, we got auto healing that we spoke about. So now, I've already spoken about this. I don't need to talk much about it. Containerization flexibility. Even if you don't use Docker for big short things, just use it to standardize your infrastructure. Get a base image, define your operating system in that, inherit from it, and go do your work and just get all your services on it. It's not going to harm you, but definitely down the line it's going to help you, because it's going to reduce a lot of problems. Beginning with your security surface area. Once you start realizing, hey, you have to sell to enterprises, then you have to start looking into a lot many security concerns than you had imagined. In fact, we had to set up a team whose only job, team means he's a one-person team, okay? His only job is to go through all these bulletins that happens over a period of time, all bugs that are declared by OWASP or other CVSs, and then aggregate that and then find out whether our services actually has any of them or not. So yes, you will get there someday with this. So why not be ready from now? So we did speak about live rollback, live deployments, but the reason I actually added an extra slide for this is orchestration. So one of the things that we talk when we think about deployments and everything is that we miss out something what we call as the formation. Henry's favorite feature is CloudFormation. And how many of you have used CloudFormation here? Just in case if you know who Henry was, he's sitting right behind. Okay, so how many of you used CloudFormation? 1, 2, 3, 4, 5, 6. So the question is, you started using CloudFormation to ensure that every time you have a new set of similar things, you would repeat it, right? That is the only place I think you started off first using CloudFormation. So for us, using CloudFormation was in a different way. So Beanstalk already creates your CloudFormation based on what you need. So our entry into CloudFormation was more like, oh, okay, this is how my CloudFormation is, already created, looks pretty complicated. Now how do I tweak it around? Now that approach changes how you learn about AWS features. Instead of starting from scratch, you are building on top of already best practices, which you can tinker and understand what you are trying to do. So we are working with CloudFormation stacks, but we are doing some advanced things. So like when you deploy your services, also deploy a Lambda with it to do some additional work in the backend, put another SQS on top of it, so that when this deployment completes, an email will be sent somewhere, which will be read by PagerDuty and will be put somewhere else, and it goes on. So yes, so these are all orchestrated. And we don't have to worry about people not deleting resources. That is one thing everybody is worried about. Somebody leaving EC2s on, for forgetting to delete a load balancer. These are common things that happen when you are starting out as an organization. We didn't have that. We didn't waste any money on them because everything was always orchestrated by Beanstalk. And all we had to do was delete an environment in Beanstalk is equal to deleting everything that you ever created in Amazon. Oh, all right. So my notes say I should go fast on this, but no, I cannot go fast. So auto-instrumented monitoring. Now, when microservices are built, and you really want to make your microservice work, there are a lot of things that you have to deal with. Primarily, how do you ensure that your microservice is well defined That is, what is your boundary? I mean, how do you even realize, okay, what I am making is a microservice, or is it just I'm breaking a monolith into different parts? So, out of all these questions, one of the most important questions first comes in is, even if I have a microservice in place, how do I monitor it? How do I effectively monitor it? What do you get out of most orchestration services? You deploy your service and you get CPU, RAM, disk usage maybe, network latency, throughput, etc., etc. But your application is not a run-of-the-mill application. What you build, a server, is a very specific server. These generic metrics are not enough to determine the health of your server. So, what if one of your service can support a lot of network traffic and does not use CPU? And what if some service which is extremely CPU intensive and does not require much network throughput? Under that scenario, will all these generic charts and graphs that we are so happy to see, will it work? I presume that's going to give you vanity metrics and misleading information. So what we started doing is, we started using this beautiful feature for Beanstalk, which a lot of people don't realize, is EB extensions. So EB extensions are just like Docker, simple files, YAML files in your code. When you deploy your application version, the YAML file is parsed by Beanstalk. You can put any CloudFormation stack information in that. You can put application level hooks into that. That means before deployment, after deployment, pre-Docker image creation, after Docker image creation, what you want to do it in the leader machine, in the entire group. The options are limitless. The documentation could be a bit more, if people are listening, the documentation on that could be a bit more exposed. We had to actually literally tear open Beanstalk to understand what was inside it. We went into the machine, observed how it does deployment, how it goes through various scripts, and that is where we figured out how it works. Any idea how much time I have? Anyways, I really lost the track of time. Okay, so with EB extensions, we started putting metrics which are very specific to our system. That is, we started putting, how much time do we have? 2 minutes? 20 minutes. Okay, good. All right. So with custom metrics, the biggest thing that happened was we put CloudFormation stack inside them, which would define metrics, that is, from where to read this data. For example, one of our services we consider unhealthy if a lot of 429 rate limiting errors happen. So we put a matrix called rate limit 429, which will have an alarm when it hits certain requests per 429s per second. And when that happens, it automatically marks the environment as unhealthy, and that automatically cascades whatever escalation information that is required for us to get that healthy. So that's what we started doing with auto instrumentation of monitoring. How did that help? We have 30 microservices. So each of them should have at least a common base set of monitoring with additional customizations. We don't want to encounter a scenario where when a service goes down and we figure out, hey, we forgot to add monitoring systems to it. So yes, EB extensions have been helping a lot to auto-instrument things. Excuse me. Along with EB extensions, we started using RDS and Elastic Cache. One thing that started working out was RDS's size, and I'm not going much more details into people, those who, if you're not already using RDS, a lot of people say that it's limited, but for you to, can I have some water? Can I have a bottle of water? Yeah. So, at the end of the day, for us, the reliability was more important than configuring things to our liking. And we ended up having as you can say, a stable system which can help us as long as we can. Finally, let me drink this water. I think 40 minutes. Thank you. All right. So once we were done setting up the stack, that is, we said that, hey, we are going to make Docker, we are going to put EB extensions in simple GitHub Bitbucket repositories, and then we are going to simply make zip files out of them and deploy. Something which looks very trivial. Zip files, really? I mean, a lot of people say that. Zip files, okay, yes, it can be automated. We did automate, and we commented out those lines of automation because we liked clicking that button to do a deployment. And then we gave ourselves a challenge. Can we, in 48 hours, make a service that will go live and serve more than 1 million users without a single crash or an outage for 1 full week? And that's what happened. So api.getpostman.com, the service that serves APIs to people using Postman, right? You can get your data out of Postman into Postman using API. The entire service was first cut, built in 48 hours flat. And when we went live with it, again, within minutes we started getting traffic. And it sustained for 7 days without any outage. I think I'm just about done, except this is one thing that I made last moment to actually figure out what things are as per my evaluation. So these are various systems that you can use, and obviously this is bad. This is bad. The last column is definitely bad. Don't try to work with vanilla EC2, ELBs, etc., etc. That's really bad. And nobody is asking you to learn CloudFormation and all those things. Use any of these for that matter, but not the last column. But if you're using various things, couple of things in Beanstalk are way cooler. It has its downsides. Beanstalk has its problems. But we always ask ourselves, are these problems that we can live with because it does not affect end customers? Yes, maybe we can live with those problems because the benefits far outweigh the issues that we face. One of the things that a lot of people say is Beanstalk deployments take time. Some of the things that we talk about is Beanstalk configuration updates are a bit tricky. Yes, they are. The deployments take time. But I think this is the only service that provides you, I think, 4 or 5 deployment strategies. That is, you do an immutable deployment. That is, you deploy one. If it works, then spin up n instances, deploy all of them at one go, and then slowly remove the extra ones. Now, this is a very critical deployment strategy. This is very useful when you are deploying, let's say, services which has continuous WebSocket connections. Because if, let's say, you removed all the services at one go, all these will again, clients will start connecting back again. And that would start slowing your services immediately. It will build up more load and load over time, and it will go down. So deployment strategies, health management, log management, rotation, retention, customizability, all are okay-ish. Configuration management is, okay, if your servers are configured, that means they have different variables to say, okay, what are my URLs that I'm fetching data from? What is my database username? What is my database password? These configurations are very important. You would like to keep them stored in a secure place. Other than that, you want to ensure that they are accessible when you need them. So yes, that's also one thing that's very easy here. I think this solves more or less about it. I'll have some extra time for Q&A. This is Cooper. He also works with us, and he does most of the pull request reviews and barks when we have bad code. You can reach me @ Shamishish. on Twitter, or we have a Postman community page which has a Slack membership. And if you have questions regarding whatever I said, regarding how to go ahead and build your microservice infrastructure over a period of time, I would be glad to answer. Questions. Now I think I can take some questions.